Hi, hello, vanakkam. This is our third video of LeetCode 100 top likely questions. This is number 15, threesome. Okay, we'll jump into the code and description. Here, the description is given an integer array nums, return all the triplets nums I, j, k such that I not equal to j, I not equal to k, and j not equal to k, and nums I plus j plus nums of k equal to 0. Notice that the solution set must not contain a duplicate triplets. So here they're asking three number. This three numbers sum should be equal to 0. Meanwhile, I, j shouldn't be equal, I and k shouldn't be equal, j and k shouldn't be equal. So which means the indexes should not be equal, which means we should not take same index again and again in one triplet. Okay, and this is in nums input array. Here they have given on input -1, 0, 1, 2, -1, -4. This is shuffled integer. It's there is no order for it, and output we have two triplets. First one returns 0 actually. Here -1, and it returns 2. Sorry, -1, 2, it returns 0. And here same -1, 0, 1, it returns 0. So we need this actually. This is our output. We need a triplet which returns 0. Okay, this is our output. And same like that, if you see here, if there is no triplet, actually there are number, but it's not giving any 0, it's not returns 0. So in this case we don't need to return anything, we can just return empty array. Same like that, third example we have three zeros, you will get 0 finally. So this is the one triplet which can return 0, so we can give it as output. Okay, we'll analyze it. So this is our input, and I'm writing that input in big font: 0, 1, 2, -1, -4. Okay, let's find the triplet here. So in this case we are going to use a 2 pointer, right? So how we can find it as a 2 pointer? It is a threesome, and only one pointer is extra maybe, right? So we can consider this as a 3 pointer, but anyways we are going to use 2 pointers as a primary, and one is going to be a static. This input, if you see this input, this is it's not in order actually, it's shuffled. So let's have a ordered list: 0, 1, 2. Okay, it is ordered now. When it is ordered, you can see one thing: it is extreme lower number, right? It is -4, and here it is extreme bigger number, +2. If there is one more 4 plus 4 or something, it's going to be here, correct? So it will be extreme positive number. So what is the use of this sorting? Yeah, if you sorting, you can get a number, you can neutralize a number very easily, correct? So for an example, you have 4 here and I have 4 here, -4 here. When you sum this -4 and plus 4, it's 0, correct? If same thing, if you do with this unsorted array, here it is minus 1 you have, right? Minus 1, and you have minus 4, it would be minus 5. So it's wrong. It don't neutralize that, right? So when you sort this array, you can neutralize the number very easily by taking a extreme lower number and by taking extreme bigger number. Okay, for an example, here you have yeah, here you have 4 and 5. I'm taking the extreme negative number first of all, minus 4, and extreme positive number, it's 5. When you take it, you would get 1. So it is a big number, right? It is greater than 0, but we need to make it 0, right? So what we should do, we need to get a big one smaller number, but left side already it is smaller. We cannot go more smaller than this, right? But in this case, we are here, we are 5, we are already in big number. We can move one step backward to get the smaller number, right? So you can move here, and when you move, you will get minus 4, and when you sum it with 4, it will become a 0. So this is the procedure we are going to use with this problem. When you solving it, you would get it easily. Now, as I said, I'm going to take this minus 4 as a primary number, as a static number, and as usual, uh, it is a 2 pointer. So I'm going to take one pointer here and another pointer at the extreme smaller number, right? And minus 1 is p1 and p2 is 2. When you sum this 2, you would get 1 plus minus 4, it is minus 3. So it is a smaller number. When it is a smaller number, what we do, we need to get the bigger number to neutralize this sequence, correct? So I'm moving this pointer to here. When I move here, it is minus 1. When it is minus 1, it's again going to give this same number, right? So there is no point to do it to here. So I'm moving one pointer again. When you move here, it is 0 plus 2, and your answer will be 2 plus minus 4, it is minus 2. Still it is not 0. Moving this pointer one place, here 1, 2, 3, and here minus 4, minus 1. Still it is minus 1, and there is one condition: we cannot overlap or cross the p1 and p2 each other. So whenever it meets, then we can stop this procedure. Okay, now let's move this static value to one pointer, minus 1. Okay, now we got the minus 1 as a static value. Now my pointer is going to be here, my first pointer, and the p2 is going to be here, right? Now what I'm going to do is, first of all, why p1 is here? Actually, we cannot start this p1 from here because we already saw this. We already got the answer for this 4, minus 1, 2. So there is no point to recalculate this same place again, right? So we can skip that. p1, and p1 is minus 1. Sum it with 2, it's going to be plus 1. and minus 1, it's 0, it is 0. So finally we got a 0. Once you got a 0, then you can store your value here. How we can write the value? Because static value points a index, that is one of the value, so we have written that. And p1 is pointing a value, this is also a minus 1, so we have written that. And p2 also pointing a value, which is 2, so we have written here. So we got one triplet, right? And once you got the triplet, we need to move two pointers, both the pointers, one step forward, p1 to one step forward, p2 to one step backward. Okay, because to stop the duplicates, to prevent from the duplicates. For an example, here also there is one minus 1. Okay, just consider that here there is one minus 1. When you do here, right, so what would be happen? p1 is moving and p2 is not moving, p2 is still standing there. Okay, I'm just removing it. Okay, just consider this as a p1, this is a minus 1. p1 is moving, and here this same procedure would happen, right? This is minus 1 and 2, answer will be 1 plus 1, and our static value is minus 1, so it becomes 0. Our answer also will become minus 1 minus 1 2. So this and this both are duplicates. As per our question, it shouldn't contain any duplicate triplets, correct? So this method will be wrong. So in this case, what we should do is we should move both the pointers as we defined. Okay, p2 should go backward and p1 should go forward. I have moved p1 forward and moved p1 backward. When I move the p1 and I got 0 plus, p2 returns, p2 points to 1, and so the answer is 1. When I sum it with static value, here I get minus 1, so finally I get 0. I got a 0. Now write down that value, minus 1 0, and p2 is, p2 points to 1. So these are the unique values, correct? We got the unique value as per our expected output. So we did it. Once we done this, and when we reach here, p1 and p2 already on place, we cannot move anywhere, right? p1 should go forward only, p2 should come backward only, so it already reached its position. We cannot move anywhere forward, anywhere else, so it's over. Now after that, we should move our static value one step ahead, and we can start same procedure again. Okay, now I'm moving here, p1 is here and p2 is here. Minus 1 is static value, right? Minus 1 is static value. So when I do it, p1 points to 0, okay, and p2 points to 2, answer is 2 plus minus 1 be 1, just 1 of the answer. So it is not 0, right? So we need to reduce the number, so p2 should go backward, one step backward. When it goes 0 plus 1, so answer would be 1 plus, and the static value is minus 1. When you add it, the answer would be 0. So you got an answer, correct? So just write it, minus 1, and p1 points to 0, p2 points to 1. oh, this value both are equal, right? So it's not comes under our constraint. It goes out of the box, right? So it's wrong. So how we can control it? To control it, we can do one thing like previously what we said. When you move the P1 and P2, if there is a -1 again, we shouldn't do that, right? We can move forward again. If for an example, as I said, if there is a -1, when you do the same calculation again, you would get that same 0, and you cannot add it here. If you add, then it would be duplicate number, right? So same procedure applies to our static value as well. Static value -1, previous value is a -1, and the current value also -1. Still there is a lot of chance to get the same value again, right? So we need to prevent it. When there is a same number after and after, then you can skip it. So while skip it, you can just go forward. Don't take this as a static value now, take it, and P1 is here, P2 is here. Okay, just erasing it. 0 is static value, and P1 points to 1, and 2 it's 3 plus 0 is 3, right? So it is still not 0, correct? So we can move the pointer, we can reduce the pointer, but the P1 and P2 already at their end, it cannot move anywhere, so it's over, game over. And yeah, that's it. You cannot move this static value also forward. So static value should give a room to stand P1 and P2, correct? So P2 and P1 should have a index. So our static value, static index should leave last two indexes. This is an important point. Our static value should leave last two indexes for P1 and P2. Okay, let's jump into the code. I will show how to code it and what are the important things are there. Before that, we will summarize it. Whatever we have done right now, as of now, we'll just summarize it and we'll go to code. Based on that, we can code. First, what we did is sort. We did the sort. Second, we made a static value. This static value should be movable until n minus 2. N means number of values in a list, and minus 2, because P2 and P1 need a room to stand, so we are giving two places for those. So n minus 2, right? So I'm giving a static value, static index minus 2, which is going to be with for loop, because it's just a flow. Okay, so there is no checkpoint or anything, it's just a flow, so we are going to use for loop here. And third, we need two pointers. We need to define two pointers. One pointer P1 is going to have I plus 1. I means static index. Okay, and P2 going to have last index. Okay, n's length going to have last index. And fourth point is total, addition, correct? Addition we are going to make. And fifth point, after the addition, we need to check that, we need to verify that is that total equal to 0 or greater than to 0 or lesser than to 0. So total check, and finally return. In this total check there can be three: zero check, or greater than, or lesser than. Okay, these three things we should check, and based on that we should make that next action. Okay, so this all thing we are going to make. I'll code and I'll show you with PyCharm. We'll debug it and you will get that easily how to do it and what's happening behind. Okay, let's meet there. Now we came to the code and we are standing at the PyCharm. Now we can read the code and step by step how it's working in background, and we'll debug it. Here we have a result and it's just initiated. Then we have a sort. Okay, as per our condition we need to sort this input array first of all, so we have sorted it, and then we have a for loop. Okay, this for loop is for just traversing, iterating through this val. Okay, this val contains a list of numbers. We need to traverse until n minus 2, so we have that formula here, and we have a if condition. As we saw previously, we need to check that, right? We need to check that previous value and current value. If both are same, then we can continue. We don't need to proceed further. So I have written this line. In this line, we need to check additionally one thing. This can be missed by most of the beginners. It would cause an error exception sometimes. So we should be careful with this. This is for index check. If I is already standing at 0, then we don't need to look at the previous one, because if index is already first index, 0th index, then we don't need to, there is no point to look at the back, right? So this is the first time it's going to run, so we need to add this condition, and then I am initializing the p1 and p2. P1 should be I minus 1, I mean static value plus 1, static index plus 1, and p2 should be length of the value, which means n. Okay, and while loop we have. This while loop shouldn't cross each other and shouldn't overlap also. So I have p1 should be lesser than p2, and here I have addition. This addition is summing up value of I, value of p1, value of p2. Once we have summed up, we have a if condition. This if condition checks that if the total is 0 or not. If it is 0, then we are just appending the result val I1, val p1, val p2 to the result, and we have p1 and p2 both are getting okay, p1 is getting incremented and p2 is getting decremented, because p2 always should be the last index, so we cannot go forward, we can come backward. So that is here. And while loop, in this while loop, okay, this is same line as we written in this place, 10th line. Okay, this line what doing is, if we have the previous number and current number are same, then we are continuing, right? So same procedure we are applying here. Here we are applying with while loop, because here we have for loop, we can continue with that. But when we are doing the while loop, right, so it don't need to run the whole process again. It can just run this whole process in just 2 lines. So it would be easy, and it don't make much problems actually. When you when you use the if condition here, right, so it would again go for the total, and again if it is matches to 0, again we would add that. So that can be an issue, like duplicate issue. It may come, it may cause that issue. So to resolve that, we can do the while loop here. What we are doing is same procedure. Val p1 previous value and p1's current index value both are same, then we are incrementing p1, and same line applies to p2 as well, and we are using p2 here. That's it, and p2 is getting decremented. And if, and we have one another condition block. Here we are checking total is 0, and here we are checking total is lesser than 0. If it is lesser than 0, then we are incrementing p1 1 index, else we are decrementing p2 1 index. Finally we can return the result. That's it. Okay, now we will just debug it. We can see what's happening behind. Okay, what's the error? Okay, there is an issue with this. Okay, now we can run it. We have initialized the result, and we are sorting it. Earlier it was unsorted, now it is sorted. This is the value we have passed. Currently this value is present in val. Moving forward, for loop is taking I as 0, 0th index is -4. So as we saw in our analysis whiteboard, we saw that -4 won't give any result, right? So we can move forward fastly. It comes to while loop, and there is no 0, so it checks with the total is -3, and we have checked with 0, so it is total is -3. So this else if will get execute, and p1 will get incremented. Now again while loop is going in and doing the same process. It just doing the same again and again. Now p1 and p2 is next numbers. p1 is 4 and p2 is 5. In this case we again incrementing p1, so p1 and p2 both are same. As per our condition, p1 should be lesser than to p2, so we skip that. Now again we go to for loop, and we are incrementing a one index, and we are taking the total, and we got 0 now. Once we got the 0, then we are checking with the if condition block. This if condition block allows us to execute itself, and result set, we are adding value to the result set and adding p1, decrementing p2, then we are checking with the previous value. If previous value is same, then we add or decrement the value p1 pointer. So we have added 1, right? So now again when we do, we again got the response -1 0 1. We got a 0, and we have added that. And now we came to third index. In this third index, if you see, while loop is continuing to execute, and we have 3 as total. So now this else if block cannot be executed because 3 is greater than 0. So else spot, it's coming to else spot. Now it's decrementing 1 from the p2. Now when we execute it, Yeah, now when we execute it, actually we couldn't execute it because we already reached it. P1 and P2 both are not satisfying this while loop condition, so we going out of the while loop. Then we are taking next index from the for loop, and for loop also cannot move anywhere. It's already reached the position. Now we are returning the result. Okay, now we came to LeetCode, and we are going to execute. Yeah, now we came to LeetCode and we are going to execute it. Okay, now running it. Reloading page. Okay, I'm running it and expecting the result. Yeah, it's passed. I'm giving submit. Okay, it's passed. So it works, right? Our time complexity and space complexity is here. Time complexity is n square, okay, because we have a sort here. This sorting algorithm would take n log n. Usually I understand n log n as 1.5. If you see log n, just consider there is a 0.5. N means 1, so you can consider this as a 1.5. And here we have a for loop. This for loop should iterate all the numbers through the val. So we have n, right, because val may contain a n number of values, so we need to iterate over through that, and it should visit all the numbers expect to. That's not a problem. Anyways, we should consider this as a order of n, right? So, and we need to find, is there any other nested for loop or while loop? Yeah, there is a nested while loop. So we should consider this as a order of n, because P1 and P2 both are traversing, right? Both are traversing rest of the elements. So this also should be considered as a order of n. And we have a while loop here, but we don't consider this as a nested for loop, nested loop actually, because this while loop, right? This while loop is checking P1 and P2 shouldn't be overlap, right? So this while loop also doing that same check actually, right? Same check, and it just decrementing some workloads from this while loop, correct? So we don't consider this as a loop, okay? So just ignore it. Here we have order of n. N means I told, right, 1. Just consider this as 1. So finally n log n. Okay, I'm just writing it here. If you see here, I have n log n, order of n log n, plus order of n plus multiply to order of n. So when you multiply this 2, it will become order of n square, correct? And when you add means you don't need to add it actually. When you just take which is bigger one is order of n square, not the n log n, right? So order of n log n doesn't matter actually. You just need to consider order of n square. That's a big one, right? So take that. So that is the time complexity of this problem. And our space complexity wise, order of n actually, because we need to return a result in the list format. This list format can contain n number of triplets, right? So you can consider this as a order of n space complexity. That's it. Okay, that's it for this video. If you have any other question, you can comment down, and I will post this problem on GitHub repository, and I will give the link and problem link on description. You can check out. Thanks. Bye for this video, and we'll meet on next video.